Just to run through the right angle triangle, just want to run through the three main trig ratios. So first of all, we have sine, then we have cosine, and then we have what's called the tangent ratio. This is often abbreviated to sine, cos, and tan. Okay, now before we start looking at this, we better be really clear that when we have a triangle, if we mark that one there, theta, we need to know where the opposite side is. So if you draw an arrow from theta, then that arrow, that will give you the opposite. The hypotenuse, or the one with the hippopotamus, is the biggest side, just like a hippo is big. So that's the hypotenuse, that's this one. And that one is opposite the right angle. So you've got the hypotenuse. So that is opposite the 90 degrees, whereas the opposite side is opposite the angle. All right, and then we have a third side there. The third side is this one here, and that one is the one that is next to the angle, and we call that one the adjacent side. So that one's the adjacent side. So think of A for angel, and the angel is standing next to the angle to look after. It looks after the angle. You could also think that the adjacent side is on the arm, okay? So it's just the arm that is here. So think of that as an arm stretching out from the angle. Okay, so that's naming the sides. Now I just want you to just name, we're just going to name the ratios. So if you found sine of the angle, that is always given as the opposite side over the hypotenuse. Cos of the angle, that is the opposite side over the hypotenuse. And then tan of the angle equals the opposite side over the adjacent side. Okay, so it's opposite over the adjacent. So if we look at this here, and we just look at the letters that are in front. So sine is opposite on hypotenuse, cos is opposite on hypotenuse, and tan is opposite on adjacent. So the actual ratios is SOH, so SOH, CAH, TOA, TOA. Now I deliberately put them in the right order. So O is opposite, is always on top for the sine, adjacent is always on top for cos, and opposite is always on top for tan. Okay, so if we were just looking at something like this, and that was 40 degrees, or actually I just might make it an angle, so we'll just make that angle, we'll make that angle A, make that angle B. I'm going to make this a 3, 4, 5 triangle. So if I go sine of A, so sine of A is the opposite side, so the opposite side would be 4, and the hypotenuse, so it's O on H, the opposite side is 4, the hypotenuse would be 5, so it's literally that fraction. If I do cos of A is the adjacent side, which is the one on the arm next to, like the A, where the, you think of where the angel is, so that's the adjacent hypotenuse. So it is A on H, so it is 3 on 5. And then when you're doing tan of A, so tan of A would be opposite on the adjacent, so it's 4 on 3. Okay, so if I swapped it now and I use B, and I wanted to find sine B, cos B, tan B, how would that actually affect it? So if you now didn't have all this on here and you wanted to find things that are related to B, there's B. The opposite is now 3. Okay, the hypotenuse will still stay the same, but the adjacent side is now 14. So when we're doing sine, we're doing sine is opposite on hypotenuse. So that means that that's going to be opposite on hypotenuse, 3 on 5. The cos, well, the cos will be, the cos is the one that's next to the b, cos of b. So that'll be 4 over the hypotenuse. So it'll be 4 on 5. Oops, sorry. So it'll be 4 on 5. 4 on 5. Okay, and tan. So tan, the opposite would be 3, and the adjacent would be 4. Opposite on adjacent, and that's the ratio for those 3 angles. So the opposite and the adjacent will swap according to where the angle is. So if the angle's up here, that's opposite, that's adjacent. But if the angle is down the bottom here, that would be opposite, that would be adjacent. So they kind of swap.